I'm back. I know you missed me so much. All right, we're going to take a look at two problems. We're going to look at number 3 and 4 or 6. We'll just do 4. We'll leave 6 for class next time. Okay, so number 3. We draw the angle itself. Now, if you look at the directions, it says, given a central angle in standard form, that's what I keep saying about these, sketch the angles and identify the smallest positive, it's going to confuse students, and the largest negative coterminal angles. Smallest positive and largest negative. If you remember what I said just a few minutes ago, there's an infinite number of solutions, an infinite. So this creates an easy way for us to always have the same answer, to always be picking the same coterminal angles, okay? All right, so 90 degrees. So if I draw my first initial, this is our 90 degree. Oop, that's not so sweet, is it? Just so crazy. Okay, so here we go. Not much better. All right, so my 90 degrees is going to be my alpha. So if I mark that, I'm just trying to make this guy a little skinnier here. If I go here, here's my alpha, which is 90 degrees. So I'm looking for two, not one, but two angles, okay? I'm looking for the smallest positive, so I'm going to look for a positive solution, but I'm looking for the smallest positive. I'm looking for the negative solution, but I'm looking for the largest negative. Keep that in mind as we go through these, okay? So positive is going to make me rotate. Got to start here. It's going to have to end in the same spot. I hope this is working because I keep hearing this weird beep. And it's going to rotate again all the way to there, right? So that's going to be 90. I added a 360 to it, if you recall, right? So I got a 90 plus a 360. Where is your calculator, Miss Tiz? 90 plus 360, that's going to give us a 450 degrees. So the smallest coterminal angle, and it cannot be coterminal to itself. I say it again. An angle cannot be coterminal to itself. So you can't give me another 90. So I had to go all the way around to get another positive angle. Okay? All right, so if that is my positive on that one, oh, I didn't want all that to happen. Then I'm looking for now a negative coterminal angle. So we have this 90 degree, and we just need to go the opposite direction. That's all we need to do. So if we just loop around this direction, this will be 90 minus 360, so we'll get negative 270 degrees for that one. And so our largest negative will be negative 270 degrees. I know that some of you are going, what? Largest negative? Remember, negative 1 is bigger than negative 2, technically, in the math world. Okay, so keep that in mind. All right, so let's try the next one. So we have number 4 over here, and we're doing negative 125 degrees. So we're going to draw that initial one, central angle in standard position, negative 125. Here's negative 90, here's negative 180, so that means it's over here somewhere. And so this angle right here is our negative 125 degrees. And so for number 4, we're looking for our smallest positive and our largest negative. Well, the largest negative is actually easier to find first, because if I go this direction and I loop, I just need to go around again. And then that would be my largest negative that is a coterminal angle to the negative that we're given. Okay, remember, you cannot be coterminal to itself. So I can't use negative 125. I got to go loop around again. So that's negative 125 and negative 360 again. Okay, so that should land us at negative 485 degrees. Negative 485 degrees. So that's negative 45. And so what happens is if I continue and go one more time, it would actually give me a smaller negative. So I need to do the reverse, and I need to go this direction instead, right? So that's 360 minus the 125, and that's going to give me a 235 degrees. Now the concept of the coterminal angles is often challenging, and especially on this little video, and we are going to definitely be practicing next time. So just take the notes, try to understand it the best that you can. If you want to try the other ones, feel free. I have more practice problems that you'll be seeing anyway. Okay? All right, we'll do the guidelines next class after we've practiced a few, because we're almost done. Reference angles. These are acute. They're so cute. Positive. Oh, that was a pretty good straight line. Ooh, look at me. I'm patting myself on the back right now. Okay, so reference angles are acute positive angles that are measured from the x-axis. It can be from the positive or negative side of the x-axis to the terminal side. All right, so we're going to sketch and we're going to find the reference angles. Now, the reference angles right now seem a little bit meaningless, but as we get into the unit circle and we start solving for equations and things like that, the reference angle is a big deal. So out of everything that we are learning today, the reference angle is the biggest thing that you guys really need to know and understand as we get into the equations, okay? So I am going to pick two of them to do with you. I'm going to do number 1, and I'm going to do, let's see, where's 4 land? I'll do 4. All right. All right, so problem number 1, I'm going to draw the angle in here. So for problem number 1, we have our 127. The green's not showing up too hot, is it? Let me get a darker color here. A little bit better. Okay, so theta is going to fall in quadrant 2. So here is our theta. So here it is. Pay attention. We need an acute angle that is also positive and is measured from the x-axis to the terminal side. Okay? So right now, if we take a look at this, this is not an acute angle. This is an obtuse angle. We need to measure it from the x-axis on either the positive or negative side. So if we come from the positive side to the terminal, we're never going to get an acute angle. So we have to measure it from here. So we're going to go this angle right here. And don't really fuss about which direction it's going, because it's really the absolute value of it. So keep that in mind. It's really the absolute value. I just don't write that in there. So then this angle right here is what I would refer to as my theta, and I write ref as a subscript. So the theta reference is this little tiny angle. So that's 180 minus your 127. 180 minus your 127 is going to give us a reference angle of 53 degrees. 53 degrees would be our reference angle. Okay, and again, right now it's kind of meaningless to you, so you'll have to keep that in mind that, we'll definitely be coming back to this. So that's our answer. That's what we're looking for. 53 degrees. Number 4, going negative, so we're going to draw our central angle in standard position. So negative 126, remember that's negative 90, negative 180, so we're going to land here, and it's going this direction, so here's our theta. Again, we need a positive angle that is measured from the x-axis to the terminal side. So again, if I look at it like the last one, I can't go this direction because this is always going to be obtuse, even though it's negative. So it means I'm going to measure this angle right here. All right, so that's negative 180 technically, and then you're finding the difference between them. Your answer has to be positive. So it's really the absolute value of this. So the reference angle right here is going to land you with, I think it was 54 degrees that I have written down here. All right. If you're wondering how that came about, play around with the numbers. You'll figure out how to get 54 looking at this value. All right. Okay, the guidelines again, which you can kind of see popping up here, we're going to worry about those in class. And lastly, this is just complementary and supplementary angles. you should know what these mean. If you don't, you need to look them up. And then these are just complementary and supplementary. Some of them will have complementaries. Some of them will have supplementaries. Some of them will have both. Like, and so there's different things, going on with these. We'll talk about 4 and 5 next class. We've done a little bit with it, but I would want your answers returned back into degrees and minutes, or degrees, minutes, seconds, DMS. Okay. So these are super easy. We'll worry about these next time. I want to see if I have, no, 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 no. Oh, look at all that. That's what you're going to be doing next time. Okay. So this is what I would like you to do since I don't have this. The one thing you have to do beyond taking notes here is on the very last page, you have what is called a unit circle. We'll define what a unit circle is and why it's called that. But the measurements that are on the unit circle, I want you to fill them in. Look up unit circle anywhere, online, whatever, and I want you to fill it in degrees only. Okay? One last thing, look it up in the book or online. It's called the unit circle. Fill in the degrees only. All right? That's what I want you to do. That's the only thing outside of the notes that you have to complete for tonight's homework. All right? I will see you next class. Have a great, great evening. Good night.